We are very, very excited about this event. This is an event on the IP transition and how we get, so to speak, across the finish line with the goal of maximizing consumer benefits and bringing new technologies on board. We are delighted today to have Henning Schulzrini to open our discussion and to stimulate us. Henning, as many of you know, is a professor at Columbia University. He is the Julian Clarence Levy Chair of Computer Science at Columbia University. He has had a distinguished academic career publishing many, many articles and in the field of computer science. He also has been department chair of the computer science department at Columbia, and he has been a technology advisor and chief technology officer at the Federal Communications Commission. So we are delighted to have Henning here to open the discussion for today. I think he's going to talk for a little while and agreed to take questions and answers. We'll stop that conversation. There may be more appetite, but we'll stop it around 1 o'clock and move on to the next panels. In the meantime, please, by all means, keep eating. Thank you.
Thank you. Thank you. Nice to see so many familiar and obviously also new faces in the crowd. I'm glad that after all these years, as you hinted at, people still care about the IP transition because it will be with us for quite a while. The hope that we could be done with that by 2018 seems optimistic at this point, but we'll get to that. So I'll give a disclaimer because if that's all you care about, you can just get a second helping of dessert. So I will not talk about three very important issues that are probably going to be one of among those most contentious issues because that's where the money is going to be, namely the competition issue, both in terms of consumer competition, namely what kind of voice services or multimedia services do consumers have access to and how does competition work, bundles and all of that, and the access competition, namely the use of copper lines in particular as the last mile access primarily for CLEC business services in that, which is obviously a highly contentious topic. And the third one, because it's an active pending issue, I won't talk about any backup power issues, although that's obviously an important consideration for many consumers in the transition itself. But I will talk about a number of items, at least briefly, and hopefully set up a more in-depth discussion for the panels who will be able to talk in much more depth about each one, or some of us at least. I'll try to kind of frame what we're really talking about when people talk about the IP transition, because it's really not one thing, it's several things going on at the same time. I'll briefly talk about legacy services that we need to worry about. My personal opinion is that those, while they get brought up all the time, are probably the least difficult because the passage of time has obviated the need for many of those, not all of those, and there are often more services that are billing system issues, as in carriers have all kinds of services on the book that nobody uses, or hardly anybody uses, or the people who use it don't even know they're still paying for it type of services, as opposed to fundamental blocks to the transition. I'll spend some amount of time on the issues of identifiers. Now, as I'll try to explain, identifiers are simultaneously the most boring thing. I mean, numbers, heck, I mean, how exciting can that get? It's like talking about the DMV, but just like the DMV, for many of us, is the most visible part of state government and an indicator of how well state government works. Phone numbers and other identifiers have become, you look at communication policy and technology, kind of linchpins of a discussion. When Congress deals with the .com Act, which is largely about who gets to manage identifiers for the internet, not phone numbers, but IP addresses, domain names, and that. Related is the issue of robocalls, as probably the single largest the one group, as usual, that has taken the best advantage of new technology are the bad guys. For most consumers, not much has changed. For the bad guys that annoy us at dinner, IP transition has happened and has been extremely beneficial, as in business enabling. Maybe that wasn't the kind of innovation that people had in mind, but hey, we got what we got. I'll talk a bit about the NG number one issue, or number one in an all IP environment. I think we now have a 15-year history that we can look back and maybe hopefully look forward as well. And very briefly, although that deserves much more attention than I'm able to devote to it here, I'll talk about the important issue, how we make sure that the IP transition enables and furthers functionally equivalent access to communication for people with disabilities, primarily people who are deaf. So when we talk about technology transitions, we're really talking about three different things. Namely, for those people who like to think in layers, we're talking about the application layer, where TDM voice transitions to VoIP. But we also have a transport network that in the old days was essentially the same thing. It didn't matter whether it was data or voice, it was the same bits essentially, that are transitioning to IP packets. And to some extent, we also have a lower layer transition, a physical and link layer transition, namely where we generally had twisted pair copper transitioning to a much richer variety of access modalities. So now, instead of just one, we now have 4 or 5 dominant ones that all underpin that transition. Each one of these poses technical opportunities and challenges. I will primarily focus on the top one, namely the transition of TDM voice to IP voice. And so the three transitions in that, namely the copper to fiber, the wired to wireless, and the circuit to packet transition, are in short all motivated not because the cool technology or because it works so much better. In many cases, it's really just a replacement one-to-one, but because of cost. It's all really about cost, maintenance cost to some large extent in that, and they pose different challenges on a technical and economic side, such as competition, capacity and quality, line power, and so on, depending on which layer you're talking about. So one way that I like to divide the problem space for the IP transition are issues that are largely intra-network, so that can and should be solved by each network making the transition, each carrier, whatever it happens to be. And there's some that are inter-network issues in the sense that even if a single carrier does something, they have to wait for somebody else to also go along with that. I will be talking about 911 as a classical inter-network problem that has become inter-network. It used to really be an intra-network problem in the old days when the phone company provided essentially the 911 service for all the way to the desktop, essentially, of the public safety answering point. Two interconnection issues, which I won't talk about here, which deserve a larger discussion separately, and I hope that will be discussed because has been one of the hindrances to actually providing those consumer benefits that everybody talks about. The slow rollout of VoLTE, for example, is partially due to that. And then maybe intra-network issues that are listed here. So if we look at what has changed, let me divide that into 3 time buckets. And so I take roughly that you could argue that if somebody from the 1980s or 1990s suddenly reawoke after a long slumber and looked at the US phone system, and true in other countries as well, particularly the landline system, and again, even though there are other pieces here, I'll focus because that's what people talk about. The IP transition is largely about landlines. Not much has changed. we got call ID, we got kind of star codes that people use to put things on hold, we got kind of answering machines, we got cordless phones. All of those emerged in the 1990s, and they're still usable today. They still pretty much do what they are. I'm not aware of any fundamentally new service that even the IP-based services that the cable companies or Fios or UVers offer any fundamentally new consumer service beyond what was available as the classical class services, the AT&T class services had. I do believe, and this is more hope than conviction, that we'll get to a model, because maybe software-defined networking is kind of a hot topic these days, that we extend the notion of software-defined networks to not just intra-network, but also to the network outside perimeter in that, so that phone-related function, voice-related function become user-programmable. I think that would actually allow a lot of innovation that we're not currently getting just by what's happening inside the network. If you look at media, really, again, not much has changed. We've pretty much turned off fax machines, unless you're law office or doctor's office. But generally speaking, it's voice plus SMS, maybe. So one of the interesting questions, and that really is primarily an interconnect issue, is can we get to a nation or a worldwide system where we get beyond voice? That and text, SMS text type of messaging in that. So far, at least, if you look at the SIP form NNI efforts, others, it's still very much voice-centric. And IMS seems to be pretty much an intra-carrier model, or if it's inter-carrier, it's voice only. So the promise that we're going to get multimedia communication hasn't quite fulfilled itself through the traditional carrier model. Obviously, we can now get cheap Snapchat and Facebook and Google Hangouts and whatever else you want, but a classical carrier-based model, for a variety of reasons, which maybe we'll get to in the panels here, hasn't really happened. The same thing in quality. I mean, it's hard to argue that compared to the 1990s, quality has actually gotten better. For most people would argue that it, on average, because of cell phone voice codecs, has actually gotten worse. Maybe we're on the cusp of doing HD voice, Dan's favorite child there, but we can make again, a question is, are we going to get there beyond the boundaries of a single network? Or is it going to be good quality when you talk within the Verizon network and the same old quality that you had in 1880 or so when you talk to somebody outside your own network? Then we've always had the nuisance calls. In the 1990s, it was your local newspaper that was enticing you to sign up for a subscription. These days, it's the IRS or Microsoft that's calling you, and I'm not sure that's much of an improvement so far. As I said, they have certainly made good use of cheap voice over IP technology where distance no longer matters, and where automation and APIs and all the stuff, good stuff, seem to be amply used by people whose primary mission is to annoy and defraud. So hopefully, and if we don't solve that problem, I think largely what I'm going to be talking about is going to be somewhat irrelevant in the sense sometimes I suspect, and this is my completely impolitic statement, that some carriers who seem to be so reluctant to do anything about robocalls seem to have a death wish for their voice services, as in maybe we can't quite get rid of it ourselves, but if we make it so unusable to consumers, maybe we'll just drop it and we can get out of the TDM business, voice consumer business indirectly. And this is probably too much conspiracy theory, but certainly the evidence of inaction sometimes leads to that suspicion. So again, programmability, I talked about that. And number one, we have seen a transition primarily in the delivery of location information for phase two, what's called phase two, namely 911 for cellular systems. That has made a big difference, and I think where the United States, through active regulatory involvement, is far ahead of most other countries that I can think of. Most countries are still delivering only location to the cell tower level for cellular 911 calls, are now struggling to do what took place in the US a decade ago. We're also seeing, I think, a number of transitions. We're now in the fourth transition, I'd say, in terms of our voice protocol stack, if you want to look at it, namely, how do we divide between the facilities access and the service itself? Clearly, the classical Bell model was a non-separable service. You got the instrument, the service, and the copper line, one company, and that was your only option for technical and obviously also economic reasons. And then after the 96 Act, we had the intentional separation, unbundled network elements, where there was an intentional model of third parties, the CLECs, providing local voice service to that. I mean, the whole act of Congress essentially all about local voice service. That lasted a few years. We won't rehash that particular bit of history. And eventually we got back to where we started from, except we got rid of long-distance competition along the way too, that we'd had since the 1980s. So we now have not so much a technical bundle, but an economic bundle, in the sense that, as you know, in almost all cases, not subscribing to voice service when you get data service or video is essentially a $0 gain. I mean, in a sense, you get the same price, even if you can get it. On a cellular side, generally, unless you get a prepay type service, can't really get unbundled voice or a package without voice in that. So we now have an integrated bundle. But there are certain early signs that at least some of the ILECs seem to be moving, and Google Fiber for that matter, to a model of a voiceless service offering to consumers, and that was always the case to businesses, obviously. Namely, where they offer a transport service, and then they say, as Google Fiber has done from the very beginning, is you're on your own if you want voice service. Go get it somewhere. We don't care. We'll provide a good network that you can run any voice service on that, and you can get this proliferation of business services like RingCentral, cloud services, or Ooma for the consumer side, or Skype for video calling, or people, maybe you just use Facebook, whatever it happens to be, but the carrier itself essentially gets out of a voice business in that. And there was an interesting filing related to that, which I get to. We also generally have a problem that we are on borrowed time for the transition. The switches that run our voice network are essentially designed in the late 1970s, and the manufacturers of those either no longer exist, like Nortel, are no longer interested in communication, like Siemens, or and sold their communication business to Nokia in this case, or are no longer interested in that particular line of business like Alcatel-Lucid. So we have a problem that you have a network, a voice network that still has economic value, that is largely run on equipment on the wireline side that is no longer made, and where spare parts are often found on eBay, and as opposed to manufactured. We also, I mentioned legacy services. People talk about those all the time. I don't want to spend too much time on those, primarily because I think we can, in each of the cases, deal with those as long as we have good IP connectivity. The problem that we've had, say, in the relatively famous Fire Island case, everybody here heard of Fire Island? Most of you have? Yep. The problem was not so much that people didn't like IP, it was that the substitute, namely 3G as a substitute, didn't do the kind of voice band data functions, low-speed data, and DSL in particular, that people expected to do. ATM, cash machine type of thing, the credit card readers, the low-end retail type of credit card readers. All of these don't work terribly well over 3G because you can't do a voice band modem over 3G. They work just fine over an IP connectivity. So the number of legacy services that don't work for consumer legacy services that don't work over the new network is actually fairly small. There are some specialty services, particularly the FAA has a number of services in pretty remote areas that do require some special features of the network. Like they use the network for timing, for example, in that digital network, a DS1 or DS3 for timing. Those are going to be more challenging, but a broad consumer transition doesn't seem to be as big a deal. So as I alluded to briefly, an interesting development that starting to essentially may change what we think of the IP transition, where the notion was, I think when everybody started that, was traditional carriers, ILECs, et cetera, because the new entrants, like the cable companies, they always were IP with one exception. But the traditional ILECs would dominate the voice business, maybe decreasing, maybe in some cases, obviously, they are also cellular providers, but they would essentially make a transition to an all IP voice network and would maintain their role maybe in a diminished importance in terms of economic value, but they would still do voice. A recent filing, which was just submitted a day or two ago, CenturyLink, and I'm just stating it as an observation, seems to imply that at least CenturyLink has kind of a Google notion that they may actually get out of the TDM business, voice business altogether, basically say, if somebody provides voice service, we no longer have a carrier obligation to do so, and somebody could be somebody else, meaning we no longer need to do residential voice. We're just going to do broadband if we're interested in that at all. Let me talk a bit about identifiers. As one problem that I think where we have a large opportunity because of a transition. It's a problem because the existing system doesn't work very well anymore. It's a legacy system that's been built up over decades in that, but we also have an opportunity because of both a technology transition and because of an administrative transition, namely the local number portability administrator transition that we're undergoing. So identifiers are both boring and critical. And that's a bad combination because then usually the only people who pay attention to that are people with an agenda or money-making opportunities, see domain names, all of that. That sucks, all these things. So identifiers are critical because they really define the scope of a network. Indeed, the Commission defines the internet and the telephone, the classical telephone network, equivalently by identifiers. In one case, the public switch network of the old style was telephone numbers. The open-ended order defines the scope of the internet by IP addresses. So in both cases, definitionally, identifiers define the network. It's not the technology, it's not the packets, it's not the underlying technology, it's the identifier. And they also are critical to security because securing identifiers is really the long-term problem. When people talk about securing the internet, surely encryption matters, all of that, but what matters at least as much from a network perspective is securing identifier bindings to principles of some sort, people, services, et cetera. So in that sense, unless we have a good understanding of identifiers, we don't really have a good understanding of a network. And indeed, you can just by 4 random examples, identifiers tend to be extremely long-lived, and they tend to acquire new uses. So a classical example is social security numbers, which initially were meant for getting your pension in old age, but now have become kind of keys to your identity kingdom and your credit record and whatever else. MAC addresses for Ethernet and others, IPv4 and IPv6 addresses, which define the transition to more scalable network, and obviously phone numbers. What's happening is, however, that as the technology lags on the classical voice side, as the promises of IMS and VoLTE take ever longer to deploy, we have had other services fill the gaps. Partially for economic, partially just because they have evolved more rapidly than traditional standards-based solutions have. So the Skypes, the KakaoTalk, the Line, the Facebook, and all of that. Indeed, now if you go into Facebook, you have a whole drop-down menu, and I'm only showing a small fraction of it, of all the services that you can add identifiers to your Facebook record to. So I guess Facebook becomes the new phone book or something. So sooner or later, we'll probably need a fold-out card, business card, that lists all your communication identifiers and, that you might have. I'm not sure that's an advance compared to where we used to be, but it's partially, I think, because there's been a gap left by the more standards-based technologies to deliver on a unified single identifier, discoverable identifier model. If we look at phone numbers, we really have had 3 stages of the evolution. We've had the part initially where the phone number mechanically defined the contact in the switching center, how you could get to where you were. And then it became your primary means of advertising your identity, the business card situation. And now, as people have things in their address book, and they use mainly name-based dialing as opposed to typing in numbers, it has become kind of an initiation identifier that you can still use when you've never met the person. Namely, this is the cat loss poster, is how else would you want to be contacted? You could put an email address on there, but the easiest way is just to put a phone number in there, because you can tear off that piece of paper and when you see that cat and call the owner. It fulfills the lost cat problem, which actually is a surprisingly large problem of intermodal transition between physical and the virtual world. Without diving into great detail, we've had and struggled throughout the communication history, if you look at identifiers, with defining an identifier that has a set of desirable properties, namely because it is a user interface. Phone numbers are something that humans need to deal with. It's not just some string of bits that we can just pass around. But we also want to make it somewhat memorable, but we also want to make it somewhat anonymous. And I believe that's why, for example, people are willing to give the grocery store your phone number, not so much your name or other identifiers. It's much easier to spell a phone number on the phone or in person than it is to spell out an email address. If you ever try to do that at like at a hotel checkout counter or rental car counter, you know how many iterations that takes until they finally recognize, yes, there is a .edu suffix. It does exist. And there is also one which we haven't solved in other identifier spaces, namely the problem of portability. We want to have a namespace that I can use independent of the provider of the services. That's obviously not universal for phone numbers, but at least in the US, probably one of the large consumer advances that has taken place, the ability to take the phone number with you, both geographically for mobile numbers and from a provider perspective, so that you have to worry about that. You can't lose your Comcast account, not because you like Comcast, but because your email address that's everywhere happens to be affiliated with your provider. I mean, that's why most people who have any intent of ever changing providers don't generally use the provider address anymore. Gmail and Hotmail and so on exist. But all of those mean that we have an inherent conflict between objectives for the identifiers. And phone numbers actually come out pretty well if I were to look at meeting the requirements. They're portable, they're international, they're reasonably easily conveyed in a variety of media, whether it's on the side of a bus or orally. They tend to be long-term constant, they're reasonably short, all of those good things that other identifiers don't necessarily have. So people have predicted the demise of telephone numbers, but because they're really none of the other alternatives are really substitutes, I don't anticipate that they all go away anytime soon. Talk about that. People worry about running out of phone numbers without going to great details unless we do something really stupid. Even if we end up assigning phone numbers to meters and light posts and parking meters and traffic signs, etc. There just aren't enough of those around to really endanger the supply of US phone numbers. There's just plenty of those around, so it's not a big deal unless we assign phone numbers to individual light switches or something like that, which doesn't seem to. Phone numbers are valuable, so there have been attempts for certain area codes that you can actually buy a 212 number, so you seem like a blue-blooded Manhattanite, if that's your thing. Illegal, all of that, but it does exist. Unfortunately, the number administration, because we've added functionality, particularly porting and pooling, to what initially just was a physical routing identifier, it has become pretty baroque. We've layered one layer of administration on top of the other, so that what seems like a pretty easy mechanism to hand out numbers is now a pretty complicated one. It's not terribly expensive, but it's messy. And makes it hard to change in particular because so many parts that need to be moved in one direction. In particular, it's not clear, and as we transition, whether long-term a number administration system that we currently have is either necessary or what we have is optimal. If I were to advocate is I think we can get by with a much simpler mechanism that both technically as well as administratively that avoids some of the complexity that we have today. I don't think anybody has appetite for another, whatever the outcome is going to be once it makes its way through the court system, another local number portability administration, transition and contract dispute in that it just seems like a whole lot of wasted effort. From a consumer perspective, the interface isn't terribly great. This is out of an ANPA report as to the different ways you can dial local numbers. There's dozens of variations with special exceptions everywhere. So maybe longer term, we'll transition to where you can at least dial 10 digits universally as opposed to this confusing mishmash that we have. We'll also have to deal with a number of policy variables, which I won't go into great detail here, namely who pays, who gets numbers. As you know, the FCC recently passed an order which allows non-traditional carrier entities, namely interconnected VoIP providers, to get numbers. What happens when entities that we don't think of as interconnected VoIP providers, say a large corporation, start treating themselves as those? Does that move towards a model that is closer to domain names, for example, where you and I can rent a domain name, license a domain name, whatever legal term you want to use? Is that the long-term trajectory? Should we separate service and numbering, just like we do for domain names, for example? That might solve a number of technical and number porting problems, for example, where you give a number to the provider as opposed to the provider giving a number to you. At least I think the transition offers opportunities to look at those issues. We can also look at, and John and others have proposed to look at numbers as a securable identifier that we can use in a number of other contexts. Currently, your email address is essentially your login identifier, if it's not your Facebook ID, your login identifier for a number of other websites. That's your standard user ID across your bank, your utility company in many cases. your newspaper, whatever it happens to be. In many cases, for security reasons, I think a phone number would be better simply because it's a little harder to circumvent redirection, and many databases already have that information. So I believe, for example, the IRS disaster could have been prevented by just simply using phone numbers as identities as opposed to knowledge-based authentication. So currently, we are in the discussion phase in the IETF about what would the number allocation system look like. Does it look like the tree model that we've had, or does it look like more of a mesh model that we could design? What kind of metadata do we want to associate with telephone numbers in that? That would essentially unify all the things we attach to numbers today. How do you want to change porting? The current porting model was developed, a number porting model was developed in a world where you didn't have internet. You had to go through a voice verification, like a third-party verification. Now that at least a large fraction of phone users also have internet connectivity, can you build a much simpler, more consumer-friendly porting mechanism? The UK actually starting to look at that for broadband services, for example, where you don't have to go through an extended rigmarole to do that. There's a working group information. I don't know, John, is it anywhere? Have we heard anything yet? Tomorrow. Okay. I'm sorry? Well, so that is a new working group on modernizing the number assignment mechanism. We had a meeting in Dallas, and we'll have one in Prague to look at that in detail. I won't go through the charter since we're running out of time here. I will point out that, just for the fun of it, 2 students working in my lab have built a pre-modern prototype, which basically shows that you can build, with relatively minimal effort, a fully distributed number assignment mechanism that allows multiple entities to assign telephone numbers without stepping onto each other's number space in that. You can guarantee that as long as people behave themselves and don't do anything intentionally bad, that a single number will only be assigned to a single entity at any given time. So you have if you go to e164.space, you can actually try it out. I'll talk briefly about what I would say is public nuisance number 1, at least according to the consumer type of feedback, namely the ability for robocallers to reach you anywhere and everywhere. This is simply an indication. The picture here is from our PBX, how easy it is to spoof a telephone number which is used by many but not all of the robocallers. So a person in my organization simply went into our local PBX, IP PBX that we have in the department, changed the phone number, and both AT&T and Verizon are more than happy to show a non-existing area code with a non-existing number. Yes, if you're really movie buff, you recognize this is the Ghostbusters number. And they're happy to do that without any complaint whatsoever. So what do we do about robocalls? I do believe we have to solve that particular problem. Otherwise, again, if you read relevant forums, many people basically no longer pick up their landline unless they recognize the number as somebody that they've dealt with before, a relative or friend or whatever. So we have to deal with those by, I'm blinded by the light here a bit, so I'm trying to make sure I read roughly what I'm seeing. Prevent call ID spoofing, the STIR working group, which I think John is going to talk about later. We need to clean up the CNUM, the naming database. We need to make it possible to allow consumer-driven filtering. I emphasize consumer-driven simply because there's been a lot of concerns that carriers either may not be incentivized or may fear that they block calls that they don't want to block because there's a fair number of robocalls which are unwanted but not illegal. This is the same for email type thing. There's lots of quote spam, which is not illegal according to the canned spam app, but people still don't like it. So in particular for robocalls, this includes polls, on landlines, and it includes politician calls. And I don't think any large organization that has a multi-million-dollar lobbying presence wants to be caught blocking the calls of the politicians that they just wrote a large check to. But third parties might feel less encumbered in that way. So we need to allow for third-party filtering, apps for smartphone, and I'll talk about a do not originate option briefly. I won't talk about STIR because we'll hear about that later. That's an IETF effort to instrumentalize the signing of numbers. I'll briefly talk about one mechanism which falls outside that scope as a short-term mechanism, namely the ability for gateway providers, of which there are only a small handful, to filter numbers that nobody actually should be legitimately originating, such as the Ghostbuster numbers, such as non-existing area codes, such as unassigned numbers, or numbers that are assigned to people that don't use gateways, and that includes the IRS, the FBI, and other favored spoofing targets that show up on your phone for usually criminal spoofing purposes. And so if we had a list of these entities that basically tell gateway providers, if you see a number like that, that call can't be real. Do something appropriate. My favorite solution is to change the area code. Area code 666 is unlikely to ever to be assigned, but it seems like a perfect match to that purpose. So who would get on that originate list is listed here. I won't go through that. So again, we need, beyond just the STIR signing, we need a mechanism that third parties can inject themselves into the call flow and do appropriate filtering, redirection, whatever the case may be. Let me briefly, before I run out of time, which I already have, talk about 911, because it is going to be the panel, but I will talk primarily about something that I think we can not so much talk about the wonders of NG911, but really talk about the problem we've had getting it deployed. And this is not the first time. This seems like, kind of just like we have Terminator 1 through 20, we have some version of Delayinator 1 through 3. And we've gone through 3 major transitions in the 911 system. Namely, the phase 2 deployment for cellular, the text to 911, which is more recent, and the deployment of NG911. And for a variety of reasons, and I've listed a few, that are probably, you can argue about those, is that the US system is uniquely designed to make it difficult to make changes to the 911 system. Again, I don't think anybody did this intentionally, but because of its diversity, because of its bottom-up model, because of a funding model, because of lack of technical resources at the local level, we have essentially 6,000 points that can block progress in that, even if they have no intention of doing so individually. It's just difficult to get around that. So the current model makes it very difficult to make rapid progress on that. And one example is the text to 911, where the map that's somewhat overlaid shows where you can get text to 911, even though all the carriers provide it now. But the PSAPs have been really slow on the uptake on that. Only 5% as of May provided at the moment. Caller location is another problem. I won't go into that. So we have to think about whether there are alternative 911 models that allow us to get to an all-IP model quicker, because one of the big dangers that I see in the IP transition is that we may actually find ourselves with a non-functioning 911 system simply because it uses technology, so-called comma trunks, that are no longer going to be available in a post-TDM world. And unless we do that soon, we're also going to run out of people who actually understand the old system simply because they're all retiring. So can we build a national model of 911 system that allows local control, all the administration funding and staffing and all of that, but scalable networks that we don't have to interconnect hundreds of selective routers, 1,000 emergency services, IP networks, all of these things at scale. And finally, we have to deal with the transition for people who need non-traditional means to communicate. We've always added, for many years, starting with the TTY, the capabilities to the voice network that allows people who cannot speak or hear to participate in at least an approximately functional equivalent way. Obviously, typing isn't quite the same, but it was an initial model of that, namely the TTY, which still exists. You still see it advertised in the subway for like the metro and so on. Can we get that to real-time text, for example? For video relay service, which is for people who speak sign language, currently this goes through an interpreter and communication assistant. Can we move to an end-to-end model where instead of talking to, say, the Social Security Administration through an interpreter that then talks to a call center agent, can't we do that directly? And finally, for IP caption telephone services, for people who can speak but not hear, can you do that through a system that automates the recognitions because the current model is financially difficult to sustain? Let me conclude. The hard parts of IP transitions are generally the ones that require inter- or inter-industry coordination. Those are the most difficult pieces. Everything else we can do locally, that takes its own path. But the ones which seem to take the longest, if you take a pattern, those are the ones that are the challenging one. Because there's limited incentive to change, limited willingness in some cases, because why should I? Is limited willingness to invest. I hate to say that. For most carriers, investment in voice services doesn't seem to usually merit a ranking or merit a listing on the annual report. It's essentially a cash business. At least they won't say that, but that's the impression I get when we talk to people about deploying STIR and other things, is kind of, I can't justify it financially, make me do it type of thing. But on the other hand, like I mentioned earlier, if carriers actually want to live up to the notion that they don't just want to be a bit pipe, the voice service is something that they already have as opposed to a new service that they need to get into. So I continue to be somewhat surprised that they essentially seem to almost abandon voice services by neglect, as opposed to using those to add value and to indeed provide those more than bit pipe services that we all seem to go after. And with that, assuming there's still time, I gladly take questions. Thank you.
We're running a little bit over, so we may truncate a bit the Q&A. We have time for maybe one or possibly two if it's short questions, but then we'd like to bring out some of the issues that Henning raised in the panel discussion. So any pressing questions for Henning? Okay, with that, let me just again thank Henning.